drive down the road, you probably aren't thinking about the process of creating that road and making sure it stays smooth and safe. But Stacy Williams is. She's conducting research at the University of Arkansas that will help set a standard for warm mix asphalt, a sustainable type of pavement that is more energy efficient and costs less than traditional asphalt.
Traditional hot mix asphalt is produced at temperatures in the range of 330 to 350 degrees Fahrenheit, where warm mix asphalts can be produced at temperatures 30, 50, even 100 degrees cooler and still have the same compaction properties.
Warm mix asphalt is produced using two methods: additives, which are added to the binder to make it more workable at lower temperatures, and a process called foaming, which mixes tiny bubbles into the binder to act as a lubricant. Williams and her students test these methods to make sure that warm mix asphalt can save money and energy and still perform as well as or better than traditional asphalt. To compare the performance of warm mix and traditional asphalt, Williams and her students use machines that simulate different road conditions.
The Highway Department for Arkansas needs regulations to tell contractors what is a good foamed warm mix design and what's not. And so our research out here is really trying to figure out how we can make lab samples mimic the effects of real-life plant foamed asphalt, and so we can correlate what we do in the lab to what happens in real life.
We can't, obviously bring a giant 10-ton roller into the lab, even though that would be fun. We need to have something on a smaller scale so that we can test it in the lab before we spend our tax dollars to build 20 miles of it in the field and then find out later that it didn't work. And so the compaction machines have a lot to do with the level of compaction, not only that happens during construction, but also what will be seen over time. We also have a wheel tracking test that tests for rutting, and we sometimes refer to it as the torture test. Worst case in our laboratory test is 50 degrees Celsius, which is about 122 Fahrenheit, submerged in water, and then a steel wheel rolling back and forth on it. So it has to endure a lot. But what we're really looking for here is what happens if we soak a sample in hot water and we put it through a freeze-thaw cycle. How well does it hold up after that type of torture? So what we're looking at here is not so much the traffic torture, but the environmental torture that mix will see when we go from hot summer to cold winters. And I really like to see the connection of, here's an idea, here's what we can do with it in the lab, and now I get to see it on the roadway, out in the real world.